Hello there. By now you've already completed a discovery lesson, so let's go through what you should have found. We are focusing on special right triangles. There are two types. We have the 45-45-90 and the 30-60-90. So what you should have figured out from your worksheet, working through using the Pythagorean theorem and different relationships that you know about triangles. For isosceles right triangles, that means they have the two legs of the same length. If the legs have length x, then the hypotenuse has length x square root of 2. And so that was probably the easier of the two discovery parts that you've done. For the second one here, which is the 30-60-90 triangle, if the shorter leg has length x, which is across from the 30 degrees, then the longer leg has length x square root of 3, and the hypotenuse has length 2x, so it's double the length. So let's take a look at that in a picture form, because I always like to use pictures and kind of further it from there. So we have the 45-45-90 triangle. You can see the two legs are the same length, x and x. And if you were to go through and calculate, you would have found it would be x squared root of 2, and that happened every single time. So what I like to do, and you don't have to do this, but it's just the way that I like to work through these problems, is write things out in words. Okay, so to find the length of the hypotenuse, it's always my leg times the square root of 2. And now this is going to be useful for us for solving problems, and we can substitute in things that we know to find the things that we don't know. So now for the 30-60-90 triangles, everything is based upon the shorter leg. Now think back to the inequality stuff. The shorter leg is across from the smallest angle. So everything is based upon the fact that we're going to call that x. So we have two relationships here. The first thing is that the hypotenuse is always 2 times the short leg. So again, I like to write it out in words because sometimes it's easier to understand. To find the length of the longer leg, which is across from the 60, it's always taking the short and multiplying that by the square root of 3. So again, when we're solving problems, which is coming in the next couple of examples, I'm going to use this kind of terminology here and substitute values into these, and you'll see how they work out. Before we do that, we need to make sure we know how to rationalize the denominator. So in the Pythagorean theorem video, the last one we went through to how to simplify radicals and everything like that, when we solve problems like this, we're going to have to end up rationalizing the denominator. So in these guys here, we are going to solve for x, because we're going to be doing that in our examples with the triangles. And what we want to do here is, whenever we solve a problem like this first one on the left, we always are going to divide both sides by the square root of 2 or square root of 3 or whatever the square root is, because we want to get x by itself. Now this is just a number, so on the right hand side, these guys cancel out. And what I'm left with is 8 over the square root of 2. Now the thing to keep in mind here is that radicals are not allowed in the denominator. And so what we do is called rationalizing the denominator, because in the denominator is a square root of 2, which is an irrational number. So what we want to do to get rid of it is turn it into a whole number. And what I want to do that with is multiply the bottom by the square root of 2. Now I'm not allowed to just multiply the bottom by the square root of 2. I have to multiply the top and the bottom by the square root of 2 because it's a form of 1. And so when I do that, I'm on the top, I can't actually multiply 8 and square root of 2, so I'm going to leave it as just 8 square root of 2. But on the bottom, we end up with the square root of 4, but in other words, we have the number 2. So you see now we went from the square root of 2 to a positive 2. And now from here, you want to make sure you can simplify this as far as possible. 8 divided by 2 is 4. So the value of x is 4 square root of 2. Okay, so let's do another example with that. And there's lots of different ways that we can do this, just kind of showing you the basics to hopefully apply to every single one. So this next one here, again, I'm going to go ahead and divide by the square root of 2. So this example is different because it has a radical in it already. So what happens on the right is they cancel. On the left-hand side, though, I still have the radical in the denominator, and I'm going to multiply only by that radical. There's no point in doing anything with the 3 because it's in the numerator, and we're only focusing on the denominator. So now up top, when I go to simplify it, the square root of 2 and the square root of 3 can actually be multiplied. And so what I have here is 2 and then square root of 6. Because 2 times 3 is 6. And on the bottom, we just discussed on the left-hand side, if I do square root of 2 times square root of 2, I get square root of 4. And we know that the square root of 4 is 2. Well, the last thing you want to do is make sure you're simplifying, and 2 divided by 2 gives us 1. So the value of x in this problem is just square root of 6. All right, let's do one more here. So you saw these are probably ones that you'll see when it comes to problems like the 45-45-90 triangles, because they have the square root of 2 for the hypotenuse. But the ones for the 30-60-90 has square roots of 3. Okay, so in this one here, if I'm going to solve for x, I'm going to divide both sides by 3, if I can get this to draw 3. Okay, so divide by square root of 3, and on the right-hand side, it cancels. Again, we have a radical in the denominator, so I'm going to go ahead and rationalize. So I'm going to multiply the top and the bottom now by square root of 3, because that's what's in the denominator. So 9 doesn't have anything to multiply by. Square root of 3 and square root of 5 multiplies to give us square root of 15. And on the bottom, square root of 3 times square root of 3 gives us back 3. Now when I go through and divide things, you noticed on the first one I didn't do it, or the second one, make sure you don't do the 15 divided by 3. You only do it with numbers you can kind of work with. So 9 divided by 3 is 3, and then we have the square root of 15. Now you want to just double check to make sure that 15 has nothing that's a perfect square into it. Make sure that's done. In this case, there is none, so that problem is completed. All right, so let's go ahead and actually apply that to some examples. So here's our first one. We're going to solve for y, which is also going to be the same value of this guy over here. They're going to be the same. And so thinking back to that first thing that you wrote down is that the hypotenuse is equal to the leg times the square root of 2. So I'm going to write that down. Okay, so I have hypotenuse is equal to our leg times the square root of 2. And what I'm going to do now is go ahead and start writing in all that I know. So the hypotenuse I see is 18. The leg, I don't know, but I'm calling it that variable I'm giving to it, is y times the square root of 2. And do you see how now it's like the first couple problems you just did? So let's go ahead through that and let's divide by the square root of 2 because we want to isolate the y by itself. And since on the left-hand side we have a number, a radical in the denominator, we're going to have to rationalize. So I'm going to multiply the top and the bottom by the square root of 2. I end up with 18 square root of 2 on the top. Square root of 2 times square root of 2 is a positive 2. And finally, we're going to simplify this down, and we get 9 square root of 2. So that's equal to our y value, which is both of those legs. So you see how I kind of substituted everything into everything with words. I like doing that because I get a better visual than just that diagram before. All right, so this one's a 30, 60, 90 triangle. So I'm going to solve for x. I'm going to call this guy y. So go ahead and draw that in as well. We're going to get both of those. And what I'm noticing here is that this is across from the 90, so this is the hypotenuse. So before I can get anything across from the 60, I need to get stuff that's across from the 30. And that's always the case. You have to have the short leg in order to do anything else because the two relationships deal with the short leg. So let's first talk about the hypotenuse. So the hypotenuse is equal to 2 times the short. And so if I substitute some values in, I know that 36 is equal to 2 times the short, and the short leg is known as x. So in this one, it's a little bit easier than the other ones. We're going to go ahead and divide both sides by 2, and that cancels. And 36 divided by 2 is 18. So I found my short leg, which was x. So now I'm going to find the long leg, which is the y value. And so what I know about the long leg is that long is equal to the short times the square root of 3. So substituting in our stuff, I have y equals, because that's long, 18 is the short leg, so 18 times the square root of 3. I can't do anything at this point. This problem is now done. I've already solved for everything. It says y equals. I don't have to move anything around, so don't divide by square root of 3. There's no point in doing so. So this problem is done. So the x value is 18, and y value is 18 square root of 3. Okay, so this is the last one that we're going to do here. We're going to find the values of a, b, and c. And as you can see, I've got two triangles that make up this triangle here. On the left-hand side is a 45, 45, 90, and on the right-hand side is a 30, 60, 90. And I'm given one value here, which is 18 square root of 2. So my goal first is to find a. And so what I'm given for that one is the hypotenuse. So the hypotenuse in a 45 is equal to the leg times the square root of 2. So let's substitute in what we know. The hypotenuse is 18 square root of 2 is equal to a times square root of 2. So I've substituted everything I know. I'm trying to get the variable by itself, so I'm going to divide both sides by the square root of 2. Now, if you don't need to do this process, that's great. If you need to do this every time, continue doing so. So what happens here is the square root of 2's on the right cancel. And the nice thing is on the left-hand side, the square root of 2's also cancel. If they're on the top and the bottom, go ahead and cancel them out. What I'm left with here is 18 is equal to the value of a. What that is our long leg. So what we need to do now is find the value of b, because that's our short leg. Well, in a 30, 60, 90 triangle, the long leg is equal to the short times the square root of 3. So let's go ahead and substitute those values in. The long leg is 18, the short leg is the variable b, and the square root of 3. So we just discussed how we solve these. We want to divide both sides by the square root of 3. So we're trying to isolate the b all by itself. I have a radical in the denominator. I'm not allowed to have that. So now I need to multiply the top and the bottom by the square root of 3. Sorry for my handwriting there. Hopefully you're listening and not just watching. So what happens at the top is the 18 and the square root of 3 end up next to each other. And on the bottom, we end up 3. Now we can go ahead and simplify this down farther because 18 and 3, we end up with 6 square root of 3. So that's our B value. So I found that A is 18 and B is 6 square root of 3. So that's our short leg now. The last thing we need to do now is find C. That's our hypotenuse. And in a 30, 60, 90 triangle, the hypotenuse is 2 times the short. And so I'm going to substitute my values in for C. It's equal to 2 times 6 square root 3. And what's nice here is the 2 and the 6 multiply to give us 12 square root of 3. We don't have to do anything further than that, no rationalizing or anything like that. That's it for this video. Let us know if you have any questions. It's a matter of making sure you rationalize your numbers, and sometimes you're going to have to manipulate some fractions. So keep that in mind moving forward. And let us know if you have any questions.